there that have the pink rocks kind of shooting through them. Those are all metamorphic and granite-type igneous rocks. And if you go to the other side of the river over here and look at all the terraces on those sides, they're all carrying almost an exact match to that type of rock coming out of the Gunnison. So it's draining that area, it'll carry out that type of rock. Well, the North Fork is starting up here in the West Elk Mountains, and those mountains are quite different. They're younger, they're made out of a type of rock that we call porphyry. So it's just an igneous rock that has big crystals in it. And then there are some mango shale sedimentary rocks that get baked up there by the magmas, and they turn into this black rock that we call hornfels. And then the North Fork is also carrying basalts from Grand Mesa. They kind of come down from the side streets like LaRue Creek. And if we go around and look at this right here, or if we go down and look at this whole area where Pleasure Park is right now, we start finding pieces of porphyry, hornfels, and basalt in that area. So this side of the river is reflecting the North Fork and the types of materials it's bringing down. That side's reflecting the Gunnison and the types of materials it's bringing down. So it's not until a mile or two down below us that we actually see those rocks start to mix together a little bit more. And even if we're on an ancient terrace, it's just because of this. It's because of the two rivers flowing together, and they actually flow kind of separately from each other for a while. You see this really composition on it. Now this terrace right here, we look around, and the gray rock, the light gray rock you see, the little white pieces that are in it, that's the porphyry right there. That's what the West Elk Mountains are made out of. So Mount Lamborn, Land's End Peak, all of those, they were once a magma chamber, or different magma chambers that were down beneath the ground. By the way, it's not a volcano like you may have heard, because volcanoes break up through the ground surface, and they don't make a rock that looks like this because they cool too quick. This is evidence of an underground magma chamber, and the magma pushed up until the rock gave way, and then started filling in a void and pushing up the rock above it as it went. It would cook that rock in there, and it would push it up over the top and make the rocks near the surface really weak. And now erosion has gone around those mountains. It's stripped away the weak rock on the sides, and it's left a real hard rock in the center, just like this. And I call those mountains the Hershey Kisses, just because they look just like that. They look like these big gumdrops.
So is it a laccolith then?
So it's what they call a laccolith.
Okay.
And that's just a fancy geologic word that means Hershey's Kiss. See, geologists, the Geology Dictionary is right behind the medical dictionary of having the most words that are invented just for geology. So, you know, if something looks like a Hershey's Kiss, we'll call it a laccolith. What the heck? So we'll
in the Lamb on the side of Mount Lamborn?
Yeah, and there's something else going on there at the Lamb on Lamborn. It's had some hydrothermal alteration, which means that some real hot waters have gone through, and it's kind of taken a porphyry like this, and it's weathered it really, really badly. But it all took place underground before it was ever exposed in the side like that. Yes? You know, the water will take through, it'll dissolve and bring through different elements with it. And so when you see red rocks, they've usually had some kind of iron brought through, and then it will hit a difference in the pH, and then the iron precipitates out of it. So usually whenever you see red rocks, iron's been transported from somewhere else, and then either just dumped right there as kind of its own substance, or else it flows through the pores in the rock, and it does their deposits on a microscopic scale. Yeah, that's usually what you see. Now the black rocks, look around for the black certain circumstances. And we can use this to tell that this is a North Fork River gravel. And then the other thing to look for, let's see if we can find one real quick. Oh, right here, look for the kind of dark Swiss cheese looking rocks, like this one right here. This is a piece of basalt, and this is something that actually did erupt and flow over the grounds. And when these things erupt and get to the ground surface, they've got air bubbles. And as they flow along, the air bubbles will stay with them, and sometimes those air bubbles harden in place. And being geologists, you know, we give them a name. We call them vesicular basalts. And these are called vesicles right there. That's a fancy word that means air pocket or air hole. But this is all stuff that originally came from way, way up on top of Grand Mesa. And it would have been brought down creeks like LaRue Creek and Jay Creek and all those. And over time, over several cycles, we'll take them out to the river. So the river rocks are usually really rounded. Rivers are really efficient at sorting things. So if you look at the size range that we have right in here, we'll have something that's maybe about this big down to sand size, but not really anything bigger than that. So these rivers were carrying a lot of sediment, a lot of